All right, this is the AP related rates and implicit worksheet. So we're looking at some of these free response questions that include related rates problems. So here's a question. Let's see. I'm just taking a look through the packet. These are usually calculator problems. However, if it is problem 5 or 6, I'm not sure what year these tests came from. Questions 5 and 6 are usually non-calculator. So let's go ahead and do this without for most of these. Okay. As shown in the figure above, water is draining from a conical tank with a height 12 feet in diameter, 8 feet into a cylindrical tank that has a base area of 400 pi square feet. That's a ton of information. They have given us some of this labeled into the picture. I want to right now get rid of this 8 and make it a radius of 4 feet. So right now, I'm just going to write down some stuff that I know out to the side because I haven't read the question yet. So I know that the max height of this cone is 12 feet, and that's happening when the radius is 4 feet. And that means, remember, with a cone, we usually have a relationship of that means h over r is 12 over 4, or h is 3r, or h over 3 is r. Just depends on which one of those we're going to use, depending on what they give us. The depth h in feet of the water in the conical tank is changing at a rate of h minus 12 feet per minute. So dh dt is not a number. This time it's a function, h minus 12 feet per minute. The volume of a cone with a radius, they give us the volume formula. Okay, so part A just says, write an expression for the volume of water in the conical tank as a function of h. This just means h is the only input. So for part A, instead of 1/3 pi r squared times h, we want to change this to, I'm going to make 1/3 pi, just pi over 3. We need to change r squared to h over 3 squared times h. So now instead of volume being a function of radius and height, now it's just a function of height. Clean this up a bit. Volume is, so this would be pi over 3 times h squared over 9. So 3 times 9 is 27, and then times h to the third. So this is it for part A. We're done with part A. Now part B, come down here with this. At what rate is the volume of the water in the conical tank changing when h equals 3? Indicate units of measure. So this is our know, find, use, right? So we know, I'm going to rewrite some of the stuff that we know. dh dt is equal to h minus 12. They want me to find dv dt, the rate at which the volume is changing, when h equals 3. And I'm going to use my volume of a cone function, but the one that's only in terms of h from part A. So I'm going to use v equals pi over 27 h to the third. All right, so what do we do with this? We take the derivative with respect to t of both sides. All right, so this becomes dv dt. I use power rule here, so 3 pi over 27 becomes pi over 9, h squared. And I have the chain rule here because I took the derivative of an h variable with respect to t. So you need a dh dt. And normally we plug a number into this, but remember we have an expression that says dh dt is h minus 12. So dv dt when h equals 3 is equal to pi over 9 times 3 squared times h minus 12. And h minus 12 is 3. So I guess if you want this in a different step, you could do this. Pi over 9 h squared times h minus 12. I don't think you have to write this separately, but that's where that's coming from. All right, and then let's clean this up. So dv dt is equal to 9 divided by 9 is just pi times -9, so -9 pi. Indicate units of measure. We're talking about volume. The measurements are in feet, so this is going to be cubic feet per hour. Let me check that. Yes, we had, oh no, not per hour, feet per minute. See, good thing I checked. I don't want to lose a point just because of the labeling. That would be silly. So this is my answer. Back here, this was my final answer. And then let's look at part C. Let y be the depth in feet of the water in the cylindrical tank. At what rate is y changing when h equals 3? Indicate units of measure. So this is another no, find, use, but we have to, we're not explicitly told a lot of the information that we actually do know for this. So what kind of stuff do I know? Well, let's think about this first of all. The rate at which the volume of water is leaving the cone, that's the same rate at which the volume of water is entering the cylinder. So because I just did part T, I do know that dV dt for the cylinder, you don't have to specify this for your AP test, but dV dt is equal to positive 9 pi cubic feet per minute. And that's because, again, the water leaving the cone is entering the cylinder, so they're leaving and entering at the same rate. I also know dH dt. I don't think that I need that. You could list it again. Not sure. What do they want me to find? Good question. Let me read it again. They want me to find dy dt when h equals 3. And that's kind of like, wait, I have a y and an h. What's happening there? We will figure that out. Y is the height here of the water, or the depth, I should say. Indicate units of measure. So what are we going to use? We don't want to use the volume of a cone. That's not going to work out. But I do want to use the volume of a cylinder. And volume of a cylinder, in general, it's the area of the base, which is a circle, times the height. And the area of the base is not changing. They gave us the area of the base. It's 400 square feet. So I'm not plugging a number into this one. I know that the volume is equal to 400 pi, right? 400 pi, there we go, times the height. And the height is not h, it's y. So then when I take the derivative with respect to t of both sides of this equation, I'll make this dV dt. The derivative of 400 pi y is 400 pi. And then I need to chain rule by saying times dy dt. And again, we know dV dt when h equals 3, it is positive 9 pi. And I can solve this for dy dt by dividing by 400 pi. So the pi's will cancel out. I will get 9 over 400. And I need units of measure. The depth of this tank is a linear measurement. It's not an area or a volume. So it is back to feet per minute equals dy dt. This answer makes sense. It's positive because the cylinder is taking on water, so y is increasing. All right, let's take a look at the second problem. This one's from 2002. The reason I put this on here is it's kind of nice for you to Google the scoring guidelines and see what are you getting points for, what do you have to write, what are they looking for on these. I'm not going to take the time to do that now, but you're welcome to. A container has the shape of an open right circular cone as shown in the figure above. The height of the container is 10 centimeters, and again, diameter of the opening is 10. So right away, as soon as I see a diameter, I rewrite it as a radius. So h equals 10 when r equals 5. In other words, h over r equals 10 over 5. That means that h equals 2r, or h over 2 equals r. I like to just get this established before I go on so that I have this relationship. Water in the container is evaporating so that its depth is changing at a constant rate of negative 3/10 centimeters per hour. Negative because water is leaving this cone. They give me volume of a cone formula. Part A says find the volume of water in the container when H equals 5. Indicate units of measure. That's amazingly easy, right? It's sort of like misleadingly easy. They just want you to find volume when H is 5. So when H is 5, what is R equal to? So R would equal 5 over 2, right? Or 2.5. They have this half relationship. So V would equal pi over 3 times R squared, so 25 over 4, times H, which is 5. I'm going to simplify that. 25 times 5 is 125 times pi divided by 12. What is the label on this? We're talking about a volume, and the units are measured in centimeters, so cubic centimeters. All right. Part B. Find the rate of change of the volume of the water in the container with respect to time when H equals 5. Indicate units of measure. Okay, so this is no, find, use. You don't have to write no, find, use for the AP test. I just like to have this so I'm establishing the things I do know. So remember, they did give us a rate. We should always have a rate or an expression for a rate that we know. We know dH dt is negative 3/10 centimeters per hour. They want me to find the rate of change of the volume, dV dt, when H equals 5. And I'm going to use, now I haven't made this adjustment on the volume equation yet, but I don't know anything about dr dt. So I don't want to use the original volume equation. I want to change this to V equals pi over 3. And remember back here, we plugged in R squared was, show this here, it was H over 2 in general, squared, times H. So this would become pi over 12, 3 times 2 squared, and then I should have H to the third. All right, so now I want to take the derivative with respect to time of both sides of this equation. And I would get dV dt equals 3 pi over 12, so pi over 4, H squared dH dt. We have dH dt, it's negative 3/10. We're supposed to plug in H as 5. So dV dt when H equals 5 is equal to 25 pi over 4. I just put in 5 squared there, times negative 3/10. Can do a bit of simplifying here. I can divide by 5. Divide by 5. So I'm getting dV dt when H equals 5 is negative 15 pi over 8. You are not required to simplify. You could have just left your answer back here. I think it's good to practice simplifying, though, because a lot of times it's those little skills that we kind of tend to mess up somewhere along the line, and that causes us to get something wrong. But it's better to practice it than just not do it. The label is cubic centimeters per hour. All right, part C. Show the rate of change of the volume in the water in the container due to evaporation is directly proportional to the exposed surface area of the water. What is the constant of proportionality? So they want me to show that the rate of change of the volume, dV dt, is directly proportional. That just means there's some constant, let's call it K, multiplied by the surface area of the exposed surface of the water. The exposed surface is a circle, and in general, its surface area would be pi r squared. So show that dV dt is equal to K times pi r squared. All right, so let's see. We have a volume equation to start with, but instead of using the H version, how about we go back and use a version where we get volume in terms of R instead. So let's start here. Volume is pi over 3, and I want to leave R squared in here. So 1/3 pi r squared, and then instead of H is equal to 2R. Remember, we said that back in the beginning. So then let's clean this up a little bit. V is equal to 2 pi over 3 times 3, oh no, not 3, times R to the third. Now I'm going to say dV dt is equal to, because I'm taking the derivative with respect to t of both sides. So dV dt is equal to 2 pi over 3 times 3, 2 pi, r squared, times dr dt. Dr dt, oh wait, now see, we don't have dr dt. Oh, let's keep going with this and see what happens. So dV dt is equal to, here's our pi r squared. How about 2 dr dt times pi r squared? Okay, so I could say that that means that K is equal to 2 times dr dt. I'm not quite satisfied with that though, because I'm wondering if they want a number. So maybe let's go back and do this. What if we did use pi over 3 times, what was that volume? Oh no, pi over 12 times h to the third. So then we would get dV dt equals pi over 4 h squared dh dt. Oh, I think this is probably better. Okay, so that's equal to, dh dt was negative 3/10. So we've got negative 3 pi over 40. And then how about instead of h squared, we put in 2r, the quantity squared? So 4r squared over 40. So negative 3 pi over 10 r squared. This is probably better. All right, and what are we really looking at? Let's separate this out. Remember, we're looking for a constant of proportionality times pi r squared, which I believe we have as negative 3/10. So the constant of, is that how they asked it? Yeah, the constant of proportionality is negative 3/10. You don't need to label that, it's just a constant. But yeah, so I didn't actually need this. But actually, I don't know, if they asked me to find dr dt, now I could say 2 dr dt has to equal negative 3/10. So I could solve for that, but that's not what they asked me. All right, that finishes this one. Let's take a look at the next one. We have a cylinder. Now in this one, we can only do part A right now. We will be able to do the next two parts a bit later in the year. I think that's chapter 6 type stuff for us. A coffee pot has the shape of a cylinder with a radius of 5 inches, as shown in the figure above. Let h be the depth of the coffee in the pot, measured in inches, where h is a function of time t measured in seconds. The volume of the coffee pot is changing, so volume is changing at a rate of negative 5 pi radical h. So I know dV dt is equal to negative 5 pi radical h cubic inches per second. And they're giving me the volume of a cylinder. Show that dH dt equals negative radical h over 5. So All right, so I know, actually, let's do this. This isn't quite no find use. This is just going through the work of this. So I'm just going to say, if you want to do no find use, I do know this. I want to find dH dt. I don't think I have a like when h is whatever, so I'm just going to leave that. What am I going to use for this? The volume formula that they gave me. So now it's pi r squared h, but the radius is not changing in this cylinder. The radius is 5. So I need to use v equals 25 pi h. If you don't make that substitution and you assume r is variable, then if you correctly differentiate, you're going to do product rule. You'll have dr dt's and you won't have anything to plug into that. So now I want to take the derivative with respect to t of both sides. And this becomes dv dt equals 25 pi dh dt. Remember, they gave us dv dt is negative 5 pi radical h. And we're just supposed to show that dh dt equals negative h over 5. So I'm going to show that negative radical h over 5. So I'm going to show my division here. And then I can say, yeah, this simplifies. Negative 5 over 25 is negative radical h over 5 for dh dt. All right, number 3. No picture for this one. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. The oil slick forms a right circular cylinder, of course it does, with both radius and height changing with time. Okay, so they're giving us a volume formula. At the instant when the radius of the oil slick is 100 centimeters and the height is 0.5 centimeters, the radius is increasing at a rate of 2.5 centimeters per minute. At this instant, what is the rate of change of the height of the oil slick with respect to time in centimeters per minute? There's a ton of information for this. Again, we can only do part A so far. We can do B and C later. What do we know? Let's go back up here. Volume is increasing, so at a rate. So dV dt is equal to positive 2,000 cubic centimeters per minute. I know that. I also know dr dt just when, let's see, the radius of the oil slick, let's see, the radius when r equals 100 and h equals 0.5, I know that dr dt is increasing, so positive 2.5 centimeters per minute. They're asking me to find dh dt when, again, r equals 100 and h equals 0.5. All right, so I have dr dt and dv dt. They want me to find dh dt. That means in this one, I am not, and we're talking about a cylinder anyway, so I am not going to replace an r or an h. I don't have a relationship between r and h. They're both changing. This is a cylinder that's getting wider and taller, right, as the oil pours in. So we are going to use volume equals pi r squared h. So this is one where I cannot avoid the product rule. If I want to take the derivative of both sides of this equation, the left side is easy, dv dt. The right side, you need product rule. So make sure you're not just multiplying these two derivatives together. So I'm going to do first times derivative of the second plus second times derivative of the first. Maybe I'll do that. And then I'm going to sub in what I know. So dv dt is 2,000. It equals pi times r, which is Let's make r 5, or no, wait, r is not 5 over 2. Regular r is 100, so 100 squared is 1, 2, 3. I have 4. 100 times 100 has 4 zeros in it, so 10,000. Times dh dt, we don't know. That's what we're trying to find. Plus, the height is 1/2 times 2 pi times 100. dr dt is, let's make that 5 over 2 instead of 2.5. Again, this is like problem number 3. The way our calculus test is set up is 1 and 2 are calculator and 3 through 6 are not. So I'm assuming this is not calculator. So I want to clean this up a bit. So this is 10,000 pi times dh dt. 1/2 times 2 is just 100 pi. This is 500 pi over 2, which is 250 pi. Right? 100 times 5 is 500, divided by 2 is 250. There's still a pi there. So 2,000 minus 250 pi divided by 10,000 pi. Yes, I can simplify that, but I'm not required to. I could divide everything at the very least by 10, and then after that by, I would assume 25. But again, you're not required to. And at this point, it's like, if I'm doing an actual AP test, I don't want to waste time on that and risk getting the wrong answer. Or just like when it comes down to time, I don't want to waste time on that. Let's see. Anything else to do on that one? No. All right. Number 5. They love giving us a table for these problems. So here's a table. We can only do part B right now for this one. Let's see. Number 5. The volume of a spherical hot air balloon expands as the air inside the balloon is heated. The radius of the balloon is modeled by a twice differentiable function. That just means r prime exists for all t in the domain, and so does r double prime. That means we have a continuous function as well. R is continuous. I know that for sure. I don't know if that matters, but I know that. For 0 to 12 times, the graph of r is concave down. We do know that means that r double prime is less than 0, r prime is decreasing. Again, do I need to know that? I don't know. I'm just listing stuff I know. The table above gives selected values for the rate of change, r prime of t, of the radius of the balloon over the time interval 0 to 12. The radius of the balloon is 30 feet when t equals 5. And here's volume of a sphere. All right, so find the rate of change of the volume with respect to time when t equals 5. So what do I know? We're looking at when t equals 5. So remember, we have r prime. I know dr dt when t equals 5. That's the same as r prime of 5. And that's 2.0 feet per minute. They want me to find the rate of change of the volume, dv dt, when t equals 5. And I'm going to use the volume of a sphere to get me here. So 4/3 pi r cubed. I'm going to differentiate with respect to time. That makes this dv dt equals 4/3 times 3 is 4 pi r squared dr dt. And remember, we know dr dt, so dv dt when t equals 5 is 4 pi times, what's the radius? Somewhere it told me what the radius was. Oh, here we go. Let's add that to our no pile. We also know that r of 5 equals 30 feet. So 30 squared is going in for r, and dr dt is 2. And so dv dt at t equals 5 is, let's see, 30 squared is 900. 8 times 900 would be 7,200 pi. And the label on that, we're talking cubic feet per minute. I have not been very careful about this in the past, but I'm trying to be better about this because I don't want to have false equivalencies. So you might see on my answer keys where it says dv dt equals this, dv dt equals this with numbers subbed in, and it really should be evaluated at t equals 5. I have not, in past years, I've not done a good job of specifying when I'm evaluating. So we'll try to be better about that this year. Okay, last problem. This is not related rates. This is implicit differentiation. So part A says, show the dy dx equals this, and you're given this curve. So first off, this is implicit because I cannot easily isolate the y and get this equation in terms of x only on the right side. So I need to say I'm going to differentiate with respect to x this curve. And I can do that as long as I differentiate with respect to x on both sides. So you need some product rule for both of these. I'm going to do first times derivative of the second, which needs a chain rule, plus second times derivative of the first. No chain rule there because you're differentiating with respect to x. And then for this one, I'm going to consider this first function negative x cubed, and the second one is y. So next one is first times derivative of the second, dy dt, plus second times derivative of the first, negative 3x squared. On the other side here, the derivative of 6, or any constant, is 0. We are supposed to be showing this. So they're telling us the answer. Don't just say dy dx equals this. Show, a step where you're combining dy dx's on one side. So dy dx, I can factor out, I've got 2xy minus x cubed, and anything else is getting sent to the other side. So I'm going to try to keep it in this order here. So I'm going to say I'm adding 3x squared y, and then I'm going to subtract the y squared. And then finally, you can say dy dx equals the answer they already gave me. And just be careful if you wrote something in a different order here, make sure you write it in the order they have it written as in their problem. Okay, so show that. Done. Did that. Part B, find all points on the curve whose x-coordinate is 1. Write an equation for the tangent line at each of these points. So points on the curve where x is 1, it means we should be plugging 1 back in for x into the curve. So 1 times y squared minus 1 times y equals 6. So that's just y squared minus y equals 6. How do I solve that? I get this quadratic equal to 0. Easy little factoring problem, y minus 3, y plus 2. I get y equals positive 3 or negative 2. What does the question say? Write an equation for the tangent line at each of these points. So I have points. So now I know that the tangent line has to occur at when x is 1, y can be 3, and 1, negative 2. So those are my points. I need slopes at these points. So I need to evaluate dy dx. Let's just start with 1, 3. Order doesn't matter here. Remember, you have dy dx given in the problem. So it's 3 times 1 times 3 minus 3 squared. I'm just going to write 9 actually. Over 2 times 1 times 3 minus 1 cubed, or just minus 1. 9 minus 9 is 0 over this non-zero, so this is equal to 0. So one tangent line is y minus 3 equals 0 times x minus 1, or just y equals 3. Either one of those would be acceptable. The other slope would be dy dx evaluated at 1, negative 2. And so that's going to be 3 times 1 times negative 2 minus negative 2 squared is 4 over 2 times 1 times negative 2 minus 1 cubed. Negative 6 minus 4 is negative 10. Over negative 4 minus 1, negative 5. That's 2. Y plus 2 equals 2 times x minus 1. That's the other tangent line equation. All right, on part C, find the x coordinate of each point on the curve where the tangent line is vertical. So the tangent line is vertical when dy dx is equal to no solution. So that's when 2xy minus x cubed, the denominator, is equal to 0. I'm going to factor this. Now this is tricky. You get x equals 0, and you get 2y would equal, if this equals 0, would equal x squared. So y would equal x squared over 2. I wouldn't solve that for x because then I'd have like a plus or minus happening. So what are we trying to do? Find the x coordinate. So x equals 0 is one of them. So x equals 0 is one of my answers. And actually, let's see. Is x equals 0 one of my answers? Let me double check. X equals 0 is not one of my answers. I have to be careful here. In my curve, if I plug 0 in, 0 times y squared minus 0 times y is not equal to 6. So 0 is not on the curve. This one I need to plug into the equation. So x times y squared minus x cubed times y is supposed to equal 6. This is x times x to the 4th, so x to the 5th over 2 minus x to the 5th over 2. Wait, minus x to the 3rd. Over 4. There we go. Equals 6. I was like, it can't be 0 equals 6. I didn't square this originally. 1/4 minus 1/2 is negative 1/4 times x to the 5th. Multiply by negative 4. You are allowed to odd root solutions. So x is the 5th root of negative 24. There's no plus or minus because it's an odd root. I'm not going to double check my answer. I don't have time, but I have a feeling this is not no solution all around. So I bet you could plug negative 24 to the 1/5 in here for x and x squared over 2 for y and get something that works. But I'm just going to leave it at that. All right, that finishes up this problem. Oh, I don't think you have a 6. If you do have a 6, I'm out of time, so I will make this video for the next thing. I need to check your packets to see if you have it.